So we're going to start by talking about the electromagnetic spectrum, and really it's more on waves, but actually we're really going to talk about light. The purpose of today is to apply our knowledge of light waves, so you're going to be watching this video and then you're going to do some labs. So for electromagnetic waves, we have to remember there are two classifications of waves. We have those that need a medium to travel through, and those are mechanical waves. And then we have those that don't need a medium to travel through, and that is going to be your electromagnetic waves. For electromagnetic waves, again, you do not need a medium to travel. They don't need to go through a slinky. They don't need to go through water. They don't need to go through the air. They can travel through the vacuum of space. Electromagnetic waves carry energy. All waves carry energy. And these waves are really fast. They travel at the speed of light, which is 300,000 kilometers per second. This can go around the world 8 times in 1 second, so it's almost instantaneous. You hear it immediately or see it immediately. The electromagnetic spectrum is used to provide us with a visual representation of these waves. So looking at the electromagnetic spectrum, you see that we have different kinds of waves, and these different kinds of waves have different properties. So we have, these are long wavelengths, and then they get shorter and shorter and shorter to shorter wavelengths, and this is a high frequency, low frequency. So ones with low frequency would be radio waves, and then you have infrared rays, and then you have your visible light spectrum, so this is where we see the colors. Then you have ultraviolet rays, X-rays, gamma rays, and this is where we get toxic. So physicists call all of these things light waves. So in everyday life, when people talk about light waves, they usually mean visible light. But visible light is only one part of the electromagnetic spectrum, and specifically it falls right here in between infrared and ultraviolet. And each different color has its own wavelength. So you can also see here that the wavelength is longer and it gets shorter as you go towards gamma rays. So there are a lot of fun things you can do with light waves. You can break them into individual colors. You can cause them to bend or spread out. Or you can manipulate them to do clever magic tricks. Light waves are also super important because we wouldn't be able to see without them. Each color has its own wavelength, and we can see that here. So the wavelength in nanometers of red is 700, orange is 600, yellow is 580, and so forth, so on. So how do we see colors? We see colors because of reflection. An object appears depending on the color an object appears depends on the color an object reflects. So the sun produces white light. It contains all of the wavelengths, all of them, red, orange, yellow, green, blue, purple. Contains all of them, and that hits this apple. And the color red is what is reflected. Red is the only thing that's reflected. Everything else is absorbed into the apple. So reflection. You need to know about reflection. We see things because they reflect light into our eyes. Reflection occurs when a wave bounces back from the surface towards the source. So you have the light creating white light, and it's hitting this rose, and the rose is reflecting red and green. So that light reflects into our eyes, and that's what we see. Examples include echoes or seeing yourself in the mirror. So for this red ball, all of the colors are being put into the ball, and the color that we see is what's being reflected. So red is what is being reflected. It absorbs all the other colors except red. But what about white? So for white, you have all the colors being reflected. So white light has all the colors, and in order to see white, it reflects all of the colors. So combining all of the colors makes white. Unlike when you have paint, that's not what you think would happen. But when you have light, white light is because it's reflecting all of the colors. Now, what do you think would happen for black? If white is the reflection of all of the colors, what would black be? black is going to absorb all of the colors, and it's even going to create heat. So when you have your black cars that are sitting in the sun with the black leather seats, it hurts a lot to get into your car and sit down on that leather because it's getting so hot, and black is absorbing all of that light and it's creating heat. So black absorbs all the colors. White reflects them all. You need to know that light travels in straight lines. So when you point a laser, it doesn't go all wonky. It goes straight to where you're pointing it, unless it hits something that makes it bend. So therefore, when that light or the laser hits a different medium, the light is forced to change speeds and it's going to bend the light wave. Now, when we bend light, we're going to be talking about refraction. This is one kind of way to bend a light wave. So refraction is when you have the bending of a wave, which causes it to change its speed as it moves from one medium to another. This is refraction. So it's going through a medium. So in this example, it's going through a glass prism. So you have your white light, which is your sunlight, and it goes through the glass prism, and it's going to show you all of the colors on the rainbow. So when light passes through a prism, this light is bending. As a result, the different colors that make up white light become separated. This happens because each of the colors have a particular wavelength, and each wavelength bends at a different angle. Here's another example of refraction. Okay, it doesn't look straight. Like when you look down into a pond and you try to catch a fish or a frog with your bare hands, and you go in and you go for it, and it ends up not being in the place where it was, or where you thought the frog was or the fish was. This is because of refraction. We have another kind of bending, and this is called diffraction. And this is when the wave bends around an obstacle or through an opening. So we have a ball here, and this is the wave, and then so it's bending around the obstacle. Or it can bend through an opening. Another way to look at this would be here. So you have your waves that are going through, and then once it hits that opening, that little tiny slit causes it to bend. So you have things that can happen with your waves, and this is called interference. And this happens when two waves meet while traveling along the same medium. So you have constructive interference and destructive interference. Constructive interference occurs when the wave amplitudes reinforce each other. They're going to build a wave that has an even bigger amplitude. So really, you're just adding those waves together. Destructive interference occurs when the wave amplitudes are opposite of each other. This is going to result in a wave that has a smaller amplitude. So you're going to subtract the waves from one another. And so let's look at an example. So if we have two waves and we're adding them together, so these are the same waves, and when we add them together, it should be double. And that's what we see, and that's constructive interference. Now these waves are opposite of each other. So if I were to lay this one on top, it's going to subtract one another. So even though it says we're adding them together, this one plus this one, they cancel each other out. And that's when you have destructive interference.